Hi Edgar. Yeah, it's a good one. Not not dissimilar to like a standard method, but there's some tricky bits in here. I think algebra wise. But with any sort of optimization question, I often think that it's actually the first bit which doesn't require the calculus that students find the most difficult. I realise I've actually trimmed the bottom bit off, but I know what the question is. Um, And the idea is that for one equation, if you just form an equation for surface area, it's going to include x and y. Now, while you can differentiate functions like that, you definitely don't know how to do that yet, and it is actually not expected that you would use the method you don't know yet. Okay, so what we're always going to have to do for this kind of question in the course is we're going to have to form two equations that both contain x and y, and then we're going to eliminate, in this case, y, because we actually want just the volume in terms of x. So the way to analyse the question is they will give you a piece of information about one quantity, and in this case it's the surface area. You must make an equation with that information. And then you'll have to show something else about another quantity. So that's the other equation that you're going to make. So, surface area one, I've got 5 bits, and the base of it, that's 2x times by y. Then the triangles are quite easy. You'd have 2x times by x and then halve it, but there are 2 of them, so we don't need to halve it, we just get 2x squared. And I can see here in your working you've actually done this correctly, but there's a bit of a trick as to writing this a bit nicer to make it fall out better. So while the square root of 2x squared is that length there, which is what you need for like the slanting sides, we can square root both of those things, because for this we are guaranteed that it has to be the positive square root, because these are lengths, they're measurements. So when you take this term here, you get root 2 lots of x. Now that you might think, got a surd as a coefficient, but you'll see that actually, because we've reduced it from an x squared, it's going to make the algebra easier. So that length that I've highlighted there is root 2 lots of x. I'm going to times that by y, and there are 2 of them. So I've got 2 lots of root 2 xy. Okay, now the reason why that falls out really nicely now is we can group together these 2 terms because they're both xy terms. You could have done it here with grouping the x squares, but it's going to be really fiddly because this x squared is underneath the square root. So by just reducing that down, that's much nicer to work with. So surface area was 600, and I'm now going to group those bits together. I've got 2 plus 2 root 2 lots of xy plus 2x squared, and you can see there's a common multiple of 2, so that gives me a bit of confidence as well that we're kind of going in the right direction, because now that 300 that was mentioned here has popped up in my calculation, which is great. There we go, lovely. So we're getting somewhere now. We want to try and make an equation for the volume, which is much simpler than the surface area. The volume is just x squared y, and simply I'm going to rearrange this equation to make y the subject, and I'm going to substitute it into there, and that's going to give me my y equation. I'm already thinking, oh, I'm on the right path, because it does say that I'm going to end up with a surd, and I've got a surd here, so that's all good. So I'm going to keep going. Let's just label them up, 1, 2. So for equation 1, I'm going to take away the x squared and divide by this term here to make y the subject. So I've got 300 minus x squared over 1 plus root 2 lots of x equals y. Looks fiddly, but I've stuck to my goal of eliminating y. Okay, so you're going to get, even if you couldn't quite get it in the form they want, you're going to probably get 4 or 5 marks at that point, right? So that's, you just got to stick to that process. A bit like the mechanics, don't necessarily know how it's going to perfectly fall out, but you've got that like toolkit and the skill to think, right, I know the strategy I'm going to try and use, and it will work. So substitute that in, and we're going to get some nice cancelling here, which is pretty cool. So here we can see that I would times the numerator by x squared, but I'm dividing by x, so I'm going to get cancel there, which is good, because I didn't really want to work with the x on the denominator. And then I can just multiply out, so I'll get v is equal to 300 x minus x cubed, but I've still got this annoying surd that I'm going to have to work with. Now, I suppose actually I've kind of... the final answer, the x is factorised out, isn't it? Okay, so... that's silly. Let's get rid of that and write it how it was. Sorry, I should have checked. There we go. So we leave it like that, but I've still got to just rationalise the denominator. So I'm going to times the top and bottom by the conjugate, and that means that the denominator will give me minus 1, and all that's going to do if I divide by minus 1 is it's going to change the signs of the third on the top. So I'm going to end up with root 2 minus 1 lots of x, and then 300 minus x squared. Okay, so I found that value of k that we wanted. Okay, which isn't nice, but it's gives you that surd. Then afterwards, it's sort of the standard thing. We're going to use differentiation to find it. So we're going to differentiate it. We're going to make it equal to 0, and jobs are good. And so I can't differentiate it straight away because it's a product. So if we multiply it out, we get 300. That's third, and then minus that. Then when we differentiate it, the x is going to cancel, so I just get this constant. Okay, equals 0, and then minus 3 lots of that third x squared. And because I've only got one x term, you can basically do, well, it's equal to 0, so the third cancels, which is lovely. And then I'm going to have minus 300 divided by 3. Oh, well, that's lovely. 100 is equal to x squared, so that value of x is going to be equal to 10. If we keep going, so then you substitute that in, so that's a 1 mark, that's really easy. But the last one, if I can just uncrop this a bit, just to, oh, come on, you bugger. But the last one says there's like a maximum value, I think it says, some sort of maximum value that x must be less than, and that is hard. Like that's tricky. That will catch out a lot of students, and it's basically you need to go back to the equation where you had a fixed limit. So this equation here is saying the surface area can be 600. It's 600 is what we get. But we can toggle and we can change this length and these lengths here, so it can be different shapes, different. You can split those measurements up to be different length, different height. Okay, and we'd end up with the same surface area. Now, the easiest way to look at this is if you make this term equal to 600, it means that this y must be 0 and you don't get a roof. Alright, so as soon as the x value increases, that means that we'd have a wider and more and a taller roof, but it wouldn't be as wide. That y value would have to get smaller to compensate for it. We'd be using more material for the ends of the roof than for this width. And if we continue to do that, this would actually shrink down to 0. Okay, so way to sort of set that up is we'd say something like x and y must be greater than 0 for the roof to be a triangular prism. Yeah, without that happening, we've actually got a two-dimensional object if y is 0, or if x was 0, we just have some like flat thing. We just have a base, a sheet of paper. We wouldn't have anything. So now that means that we're going to equate 600 equals 2x squared. So we're going to have the square root of 300. 10 root 3? Yeah, 10 root 3. So that's the biggest that x can be. Yeah? So that means that x has to be strictly less than that value. If it's just a little bit less, we'll still have some small width of y. But if it is equal to that value, we'll have y having to be equal to 0, because it will cancel out. Where are we? It will cancel out this term in your surface area formula. Okay? So yeah, that last bit's quite tricky. But often you need to go back to the equations and think. Sometimes it's like cutting out corners and then they fold up a sheet of paper. And sometimes the cut can be actually bigger than the width. So you wouldn't actually be able to fold the piece of paper up. Just to sort of show you what I mean. Imagine you've got a sheet of A4 and you're cutting corners out like this. If the cut that you make is actually bigger than half of this, you'll just cut the whole side off and you'll end up with something that won't fold up to be able to hold volume. So that's another thing that happens in those kind of questions. Anyway, I hope that's helpful, and yeah, take care.